Hello, we're back, and we're just going to do some last minute revision. We're going to look at paper 3 higher tier before the exam on Monday. Good luck for anyone who's doing that last maths exam of hopefully Maths GCSE maths you do in your life. So we're just going to have a go at this paper. Right, I've got my pen back, I've got my microphone, so happy days. So let's just have a look again. It's an hour and a half, we can use a calculator, and like we've had with all previous papers, we've got a little cheat sheet here. We've got some perimeter, area and volume, we've got the quadratic formula, we've got Pythagoras theorem, trigonometry, cos rule, sine rule, area of a triangle, some compound interest and some probability. So we'll keep those in mind, but let's get cracking. All right, so the frequency table shows the heights in centimeters of some tomato plants, and we want to draw a frequency polygon to show this information. Now, the first thing is if you've got a frequency table and the heights are in groups, so they're not individual values, but they're ranges. So, for instance, the first one is from 140 to 150. We want to go bang in the middle of each group. So, between 140 and 150 is 145. Halfway between 150 and 160 is 155. And then if we just keep going, we're going to get all of these. Just be careful because sometimes some of the groups are bigger than others, so it's not always necessarily going up in the same amount. And then we just plot these points. So for 145, we have got 7. Now between 0 and 5, we've got 10 squares. So that's going to be 2 squares for each number in the frequency. So for 7 then, that would be here, about there for 7. We've got 155 and 10. So that would be there. We've got 165 and 15. Like that. We've got 175 and 19, which should be about there. And 185 and 9. So that should be there. Lovely. And then we just use a ruler, which I'm not using at the minute, but let's just grab a different colour just so it looks slightly different. You get a straight line, join up all your points like that, but imagine I've just used a ruler. All right, and there's no need to connect it to 0 or anything like that. Just join up all of the points that you've just made. All right, number 2. So Banana Computers sold 19.3 million computers in 2017, and in 2018 they sold 18.2 million computers. We want to work out the percentage decrease in the number of computers sold. Okay, well, the first thing we want to do is look at, well, how much has it decreased? Well, it's gone from 19.3 to 18.2. So if we do a quick takeaway, that is a 1.1 million decrease. And then the percentage decrease then is just going to be 1.1 over the original number. Okay, we're back. I did the one thing you should never do going into this exam, and that is forget your calculator. But I've got it now, and so let's just do this. So it's 1.1 divided by 19.3, and we're ending up with, get me pen, 0.056994, blah, blah, blah. And then as a percentage, we just times it by 100, so that'll be 5.6994, blah, blah, blah. And then we want it to 3 significant figures. So those are our first 3 significant figures. And because the next one is a 9, this is going to round up to 5.70%. All right, so number 3, the value of a house increased by 6%. The house then had a value of 265,000. Work out the value of the house before the increase. So whatever the house was, let's say it was X, we'd times it by, well, if it's increased by 6%, that's going to be 106%, and we've ended up with 265,000. So to solve that, because we've times by 106%, we want to divide by that to get the original price. So X is going to be 265,000 divided by 106%. Just do that in our calculator, divided by 106%, and we end up with 250,000. And normally with these questions where you have to work backwards, it normally ends up being quite a nice round number, so that's why I feel a bit confident that we've done all right with that. And for other people who don't want to use the percentage but want to use the multiplier, 106% is the same as 1.06, and you could have used that instead of the percent. Okay. Right, number 4. So we've got S equals ut plus half of at squared. U is minus 5, A is 4, and T is 3. And we want to work out the value of S. So we're just going to shove all these numbers in. So S is going to equal U, which is minus 5, times T, which is 3, plus half of A, which is 4, times T squared, which is 3 squared. Okay, and then we can simplify this out. So minus 5 times 3 is minus 15. And we've got plus half of 4 is 2, and 3 squared is 9. So this is going to be minus 15 plus 2 times 9 is 18, and minus 15 plus 18 is 3. Okay, you could just shove this top thing into a calculator and it should also give you the answer 3. All right, B, we want to make A the subject of S equals ut plus half of at squared. Now the first thing, this seems like a really daft step and doesn't need to be done, but for me it just makes it a lot easier, and that's just to get the A on the left hand side just by swapping everything. So all we're doing is exactly the same, but we're putting this bit on the left instead. So we've got ut plus half of at squared equals S. So I've done absolutely nothing there, but just because in the end we want A equals something, because we want A to be the subject, I've just swapped it so it's already on that side. Okay, so the first thing is then, I want to get rid of this ut. So let's minus that from both sides. And we're going to end up with half of at squared equals S minus ut. Then what we want to do is we want to get rid of this half by the at. So let's times it by 2. That's a good way of getting rid of a half. So we're going to end up with at squared equals 2 brackets S minus ut. Finally, we want A on its own, so let's just divide by this t squared. And so finally, we're going to get A is 2 brackets S minus ut over over t squared. And there we have it. Okay, number 5. So we've got 120 people in a school canteen. 40% of the people are year 11. And the number of year 11 students in the canteen is 3 times the number of year 10 students. And the rest of the people are year 9 students. And we also have that the number of year 9 students to the number of year 10 students is in the ratio n to 1. And we want to work out the value of n. All right, well, there's a lot of stuff going on there. So whenever you get a big question like this with a lot of stuff going on, a lot of kind of text, read it all through, get a gist of what's going on, and then go back to the start. And then at any point you can figure something out, just work it out. And that should make the question a lot more straightforward. So this first bit, there are 120 people in a school canteen, and it says 40% are in year 11. So I can definitely do that. So 40% of 120. So again, we'll just do it in our calculator. So 40% times 120, and we end up with 48. So there are 48 year 11s. So let's keep that in mind. We'll highlight that. We've got 48 year 11s. Then it says the number of year 11 students in the canteen is 3 times the number of year 10 students. Well, we can divide 48 by 3, so 48 over 3 is 16, and that's how many year 10s we've got. So already we're just figuring stuff out. Then it says the rest of the people in the canteen are year 9 students. So we've got 48 plus 16 already, which is 64. And then to figure out how many are left, we're going to do 120 minus 64, which is 56, and that is year 9s. Okay, and we'll highlight that because that's a good result. Okay, so finally then, we want the number of year 9 students to the number of year 10 students to be n to 1. Well, let's just write the ratio. So year 9 is 56, so let's just write year 9 to year 10 is 56, and year 10 was 16. So we want this 16 to be 1, don't we? And to get that, we divide by 16. So we need to do that on the other side as well. So 56 divided by 16, and that is 3.5. And that must be n, so n is 3.5. Right, number 6. So Amy drives 300 miles from London to Newcastle. She drives the first 165 miles at an average speed of 60 miles an hour. And from this point, it takes Amy 3 hours and 5 minutes to complete her journey. What was Amy's average speed for the whole journey? Give your answer correct to 3 significant figures. Okay, so the first thing we want to remember is that speed is distance over time. Okay, so if we want the average speed for the whole journey, we need to know the whole distance and we need to know the whole time. Now the whole distance, they've already given us. So she drives 300 miles from London to Newcastle. So that's the total distance there. And we just need to figure out the total time then. So the first 165 miles, she's at an average speed of 60 miles an hour. Well, 60 miles an hour is lovely because there are 60 minutes in an hour. So that means she's going to drive a mile a minute. So that is going to be 165 miles. It's going to be the same as 165 minutes. Okay, and that is, if we think about 60 minutes in an hour, that is going to be 2 hours and 45 minutes. Lovely. So that's the first part of the journey. And then we know the second part of the journey is 3 hours and 5 minutes. So the total, time is going to be 2 hours and 45 minutes plus 3 hours, 5 minutes. And if we add the hours up, we get 5 hours. And if we add the minutes up, we get 50 minutes. Okay, great. So now we can work out the total speed. So the speed is going to be distance, which is 300, we knew that, and over time. Now let's write this in hours. Now 5 hours and 50 minutes, well there are 60 minutes in an hour, so 50 out of the 60 is the same as 5 out of 6. So this is going to be 300 divided by 5 for the 5 hours and 5/6 for the 50 minutes. And if we type that in our calculator, so 300 on the top, and then a mixed fraction at the bottom, 5 and 5/6. And we end up with, and we want it to 3 significant figures, so that's going to be 51.4. And that is miles per hour. So let's write that down here. Okay. Now, when you do a big question like this, it's so easy to type in something wrong or do something daft. So when you get your answer, just see if it makes sense. Now, if she's driving from London to Newcastle or wherever she was bobbing off to, this makes sense that her average speed would be 51.4. Yeah, the most you can drive is 70 on the motorway, so it's going to be less than that. If I've ended up with an answer of 300, Amy's in trouble, isn't she? Because she's driving like a mad woman. So just double check that your answer makes sense. Okay. Number 7. So potatoes cost £9 for a 12.5 kilogram bag at a farm shop, and the same type of potatoes cost £1.83 for a 2.5 kilogram bag at a supermarket. Where are the potatoes better value, at the farm shop or at the supermarket? You must show your working. Okay, well, this question is made a lot easier when you notice that 2.5 goes into 12.5. So when you times 2.5 times 5, you're going to end up with 12.5. So we know, so at the farm shop, 12.5 kilograms is £9, so that's fine. And then let me grab a different colour. And then at the supermarket, 2.5 kilograms is 183, but we want to get to 12.5 kilograms, and we've noticed that that's times 5. So all we have to do is times the price by 5. So £1.83 times 5, and that is £9.15. Okay, so that is telling me that it is cheaper at the farm shop. So let's just write that conclusion, because for the same amount of potatoes, it's 15p cheaper. So cheaper at the farm shop. Okay. Your other way of answering this question, if you didn't spot that 2.5 goes into 12.5, is you could just bring it all down to 1 kilogram. Okay, so if this is 12.5, you divide by 12.5 for the £9, and you'd end up with, so let's do 9 divided by 12.5, and we end up with £0.72, and that's obviously for 1 kilogram. So that's at the farm shop. And then if we try the supermarket as well, now this was for 2.5, so we want to divide 1.83 divided by 2.5, so 1.83 divided by 2.5, and we end up with 0.732 for 1 kilogram. So again, it's more expensive at the supermarket, and so it's cheaper at the farm shop. Okay. All right, number 8. So we've got ABCD is a trapezium, and we want to calculate the area of ABCD. Okay, well, to calculate the area of a trapezium, you need to know, well, if you imagine it flipped around, you've got your two parallel sides here, and this bit here is kind of the height of it. So you need to know the height and you need to know the length of the two parallel sides. So what we don't know is the length of this parallel side, otherwise we'd be able to just shove it into the formula straight away. So the way we need to do this is we need to somehow figure out what that is. Now, what I think I'm going to use is Pythagoras. So if I chop this trapezium into a rectangle and a right angle triangle, if it's a rectangle, we know that this is 15 centimeters, and so we can use Pythagoras to figure out this length here, and then we can take that off 12, and then we'd know what this length is here, and then we'd be okay. So let's just draw my triangle again. So we've got 15 centimeters and 17 centimeters, and this is, let's just call it x. And so with Pythagoras then, it's a squared plus b squared equals c squared. Now c squared is our longest side, so our longest side is always the one opposite the right angle. So that's 17, so 17 squared. A and b, it doesn't matter what order you put them in, so let's just say x squared plus 15 squared. Then we want to take away this 15 squared, so we're getting x squared on its own. So x squared is 17 squared minus 15 squared. And to find x, we just want to square root all of that. So 17 squared minus 15 squared. Again, just do it all in my calculator. So square root 17 squared minus 15 squared. And we get a lovely answer of 8 centimeters. Great. So this is 8 centimeters, which means that this bit here, let's just grab a different colour, which means that this bit, to make up the 12, must be 4 centimeters. And so that must be 4 centimeters as well. Okay, great. So now we've got our trapezium. So we've got that this side is 12, this side is 4, and the height is, 15. So let's just work it out. So the area of a trapezium, area of a trap, let's call it, is a plus b, the parallel sides, divided by 2, so you're finding the average, and times the height. So this is going to be 12 plus 4 divided by 2 times 15. 12 plus 4 is 16, divided by 2 is 8, and 8 times 15 is 120 centimetres squared. Okay, and again, you can use your calculator to do all that. Okay, number 9. So given that 81 times root 3 is 3 to the power n, find the value n. Alright, well we want to find this as a power of 3, so let's write everything that we've got on the left hand side as a power of 3. Now 81, well let's just think about powers of 3 for now. So 3 to the power of 1 is 3. 3 squared, 3 times 3 is 9. 3 cubed, well that's 9 times 3, which is 27. And 3 to the 4 is 27 times 3, which is 81. Okay, so we know that 81 is 3 to the power of 4 times, and then the square root of 3 is the same as saying 3 to the half. Okay, and now when you times them together, you're going to add the integers, not the integers, sorry, the indices. So that's 3 to the 4 and a half. Okay, so n is 4 and a half or 4.5. Okay, number 10. There are 5 starters, 6 main courses, and X desserts in a restaurant. And Riley says there are 130 ways of choosing a starter, a main course, and a dessert. Could he be correct? Well, what we're saying then is, so 5 starters, 5 options to start, and for each of those 5 starters, there are 6 options for a main course. So for starters and main course is 5 times 6, and then for a dessert, there are X options, so you times that by X. And he's saying that that is going to give you 130. Well, 5 times 6 is 30, so this is the same as saying that 30x is 130, and so x is 130 over 30. But if we type that into our calculator, 130 divided by 30 is 4.3 recurring, and you can't have a third of a dessert, can you? Yeah? You can't order 0.333 of a cake. So that can't be true. So x has to be an integer, yeah, whole number. So Riley is incorrect. Okay. Right, number 11. So the line AB passes through the points -2k, that's A, and 4 and 8. So I'm assuming that's B. I think that's a typo on the exam. Okay, and the gradient of AB is -2, and we want to work out the value of k. Well, there's a formula for the gradient if you've got 2 points. So the gradient is, so it is y2 minus y1 over x2 minus x1. Now, so we're saying that m is -2, so this is saying -2 equals, well, y2 is 8, y1 is k, so 8 minus k over x2, which is 4, minus -2, which is +2, which we can simplify to 6 in a sec. So we've got -2 equals 8 minus k over 6. And now what can we do with this? Well, we can times up by the 6. So 6 times -2 is -12. So -12 equals 8 minus k. Now, I don't like this minus k, so let's add it onto this side. So there we're going to get k minus 12 equals 8. And then add the 12, you're going to get that k is 20. Okay. Okay, number 12, we've got some triple brackets. So we want to expand and simplify x plus 5 times x minus 3 times 2x minus 1. Well, the first thing we want to do then is just times the first two together. So let's just times those two brackets. And what are we going to end up with? Well, let's get red. We've not had red yet, have we? So x times x is x squared. And then x times -3 is -3x. 5 times x is 5x. And plus 5 times -3 is -15. So that's those first two times together. And then we've still got this 2x minus 1. Then we can just tidy that up a little bit. So bring those x's together. So we've still got an x squared. And then minus 3x plus 5x is going to give you plus 2x. And then we've still got a minus 15. And we're timesing that by 2x minus 1. All right, well, now we're going to have to times everything in the first bracket by the second bracket. So let's times everything by 2x to start with. So we're going to get 2x cubed plus 4x squared minus 30x. And then we want to times everything in the left by minus 1. So that's going to be minus x squared minus 2x plus 15. And then we can finally bring things together. So we've got 2x cubed. So that is, let's just cross things off as we do it like terms. So we've got 2x cubed. Then how many x's have we got? Well, we've got 4x squared minus 1x squared. So that is going to be 3x squared. Then how many x's have we got? We've got minus 30 minus 2, so that's minus 32. And then finally we've got plus 15. And that is our answer. So let's just copy it out right, make sure we don't make any daft copying errors. And there we have it. Not bad. Okay, so question 13, we've got some column vectors. So we've got A is minus 2 and 3, and B is 5 minus 1. And we want to write down, firstly, A plus B. So that's going to be minus 2 and 3 plus 5 and minus 1. So with this, you just add up the matching components. So we want to add minus 2 and 5. Well, that's minus 2 plus 5 is 3. And then for the bottom one, we've got 3 plus minus 1. Well, that's 3 minus 1, which is 2. Okay. Then we want, for part 2, 2a minus b. So that's 2 lots of a, which is minus 2 and 3, minus b, which is 5 and minus 1. Well, 2 times a, we just times 2 by everything in the vector. So that's going to be minus 4 and 6, minus 5 and minus 1. So minus 4 minus 5 is minus 9, and 6 minus minus 1 is 6 plus 1, which is 7. Okay, number 14. So a car's value is decreasing by X% each year, and the car's value will decrease by 60% in 6 years. Work out the value of X. Okay, and give your answer to 2 decimal places. Well, first thing is, if it decreases by 60%, then from 100, that's going to be 40% left. Okay, so it starts off with 100%. We times it by x to the power of 6, and then we're going to end up with 40. Okay, so now if we just solve this, we divide by 100, so x to the power of 6 is 40 over 100, or 0.4. And then to get x on its own, you want the 6th root of this, so it's going to be the 6th root of 0.4. So let's just find the root button where we can put whatever we want. So root, we want the 6th root of 0.4, and we're ending up with 0.8583742189. As a percentage, that is going to be 85.73742189, and we want it to 2 decimal places, so that's going to be 85.84%. Okay. Alright, I think we're doing alright so far. So 15, it looks like we've got a circle with a triangle kind of attached to it. So A and C are points on the circumference of a circle, and BC is a tangent to the circle. Okay. Angle CAB is 29 degrees, and we want to find the size of the angle ABC. Okay. Now, what is going to help us a lot is just drawing one line, and that is going to be, so in my head, I'm thinking one of the circle theorems is that a tangent attached to a line going to the radius is 90 degrees. So if I just draw this line here, I will know that that is 90 degrees. So that might help me. But what I also know is that now I've got a triangle where this and this are both the radius, so they're both the same size, and that's going to give me an isosceles triangle. So first of all, I'm going to get that is the same as the other one, which is 29. So we've got ourselves a little isosceles triangle there. Okay, so we've got 29 and 29, so it says show all of our working. So the first thing I'm going to write is that ACO is equal to 29 since we have an isosceles triangle. Great. Now remember, the end goal is ABC, which is this one. So actually I'm thinking now, well, I've got this angle. I want to find this angle, and if we've got a triangle, I could just work out this here, and that should give it me. So ACB is going to be 29 plus 90, which is 119, since the angle between the radius and the tangent is 90. Yeah, so now we know that this whole thing is 119. And then finally, I can use the angles in a triangle rule. So we've got 29 plus 119 is 148. And then 180 minus 148 is 32. So we have that ABC is 32 since angles in a triangle add to 180. Okay, so there were just a couple of things to remember there. There was the circle theorem that this radius and this tangent are going to be at a 90-degree angle. And then it was also figuring out, well, if you've got two radiuses, they're going to be the same. And that's going to give you an isosceles triangle. And that's going to be the clues that kind of piece it together. Okay, and then just make sure we actually write the answer in the answer line. Okay, number 16. So the two triangles in the diagram are similar. Okay, so let's just draw these out separately. It always helps. So we've got A, B, E, and that is 5 centimeters, and that is 6 centimeters. And then we've also got this kind of bigger one that contains it, and that is A, C, D. And that says that this line here is 6 plus X, and this is 9 centimeters if I add up the 5 and the 4. Okay, now it says there are two possible values of X. Work out each of these values. Okay, well, there are two possibilities. Now, the obvious one is that you would think that if these are similar, then this would match up to this. So let's firstly do that then. So the first thing we're saying is, I'll just zoom out a little bit. First thing we're going to say then, so case one then is that AB corresponds to AC. Okay, so we've gone from 5 to 9. So the scale factor is 9 over 5. Yeah. And then we want to figure out what X is. So we times 6. So now we're going to make this go to X. So 6 times 9 over 5. So let's stick that in our calculator. So 6 times 9 over 5 is going to give me 10.8. Okay, and then I want to figure out X. So 10, so let's write this. X is going to be 10.8. Take away the 6, which is 4.8. Okay, so that's our first option. That's option number 1. All right, and then option 2. Now, just because they fit inside each other doesn't mean that these two are going to match. Your other option is that this 6 matches up with this 9. So our second, let's just zoom out again, just so we can see the whole thing. So our second option is that AE corresponds to AC. Well, in this case, the scale factor is 9/6, yeah, because AE is 6. Okay, and then so we do 5 times 9/6, and again we'll stick that in our calculator, so 5 times 9/6, and that gives us 7.5, and then again, so we know that 6 plus x is 7.5, so x is going to be 7.5 minus 6, which is 1.5. So those are our two options, and let's just make sure we're writing centimetres for both of them as well. All right, so number 17, so we want to show that 3 plus x plus 4 divided by x squared minus 16 over x minus 5 simplifies to ax minus b over cx minus d, where a, b, c, and d are integers. Okay, so this looks pretty complicated, but we'll just do it step by step and see how we get on. Now, the first thing I'm noticing is that I'm dividing by a fraction. Now, I don't want to do that, so let's do the keep, flip, change rule. So we'll keep everything the same. So 3 plus, we've got x plus 4. Now, we keep that the same. We change the divide to a times, and we're going to flip over the fraction. So this is x minus 5 over x squared minus 16. Great. Now, the next thing I'm noticing, this is jumping out at me. This thing here has a difference between squares. So if I just do a little side note, so x squared minus 16 is the same as, well, that's x squared minus 4 squared. So that's x plus 4, x minus 4. So let's just write the next step then. So this is 3 plus, now this x plus 4 here, I'm going to bring it up onto the fraction and times it with that. So we're going to have x plus 4 times x minus 5 divided by this thing here, x plus 4 times x minus 4, like that. Okay, and now I'm noticing that the top and the bottom have a common factor of x plus 4, so they're going to cancel each other out. So we're going to be left with 3 plus x minus 5 over x minus 4. Okay, now we want to bring this all into the same fraction, so let's times 3 by x minus 4 on the top and bottom. So this is the same as 3x minus 4 over x minus 4 plus x minus 5. Okay, then we just expand these brackets a bit, so that's 3x minus 4 plus x minus 5. Sorry, I've not expanded that properly. So 3x minus, 3 times 4 is 12 over x minus 4. And then that is going to give us 3x plus x is 4x. Minus 12 minus 5 is minus 17 over x minus 4. And that's our answer. That's how they want it. Okay, lovely. So I think we're over halfway through now. We're getting into kind of the nitty-gritty questions. So depending on what your target is, if your target's a 5 or a 6, you just kind of want to get to the middle part, do as best you can, and then try and kind of scrap for extra marks. If you are looking for 7s, 8s, and 9s, these are kind of the big questions that you really want to be tackling. So yeah, sometimes it might be better to start at the end because they're the more challenging questions when you're not as tired, and then maybe move on to the first few questions that are a bit more straightforward. Okay. So here we've got a triangular prism. So we've got 30 along the front, 20 centimetres along the side, and then we've got this angle here of 35 degrees. Now we want to calculate the size of the angle the line AF makes with the plane ABCD. Well, AF is this kind of diagonal line here. Okay, and we want the angle it makes with ABCD. Well, that's this angle here, but this has got to be in line with this diagonal here, if that makes sense, so that you've got a 2D triangle. So this is kind of like a 2D triangle that is also a right angle. So it's going across the diagonal going up, and so we want to figure out what we can. Now, we want to find out this angle here, so let's just shade that in. We want to find out this red angle here. So we want to use, I'm thinking trigonometry. So if I can figure out this side somehow, and I'm thinking I'm also going to have some joy with this, oh, if I can colour it in properly, with this side as well, I'm going to have a lot of joy. So the first thing I want to look at then is, because I've got a lot of information about this triangle here, so I'm thinking I can use trigonometry to work out this, which I'll call x. So let's just draw out that triangle. Sometimes with a big diagram, it's easier just to take it out of it. Take the small bit that you're worried about or bothered about. So I've got a right angle triangle. I've got that that's 35 and I've got that that's 20. And I want to work out x. So that is just going to be trigonometry. So let's just label our sides. So this is the hypotenuse. If that's the angle, then this is the adjacent and this is the opposite. Now I know the adjacent and I want to know the opposites. That's O and A, so I want to use TOA. So that's going to be tan of 35 is opposite over adjacent. I'm rearranging that. I'm going to have x is 20 times tan of 35. And let's see what we end up with. So 20 times tan of 35. And we end up with 14.00415076, which we'll leave like that for now. Okay, great. So that is our x. So they want it to 3 significant figures in the end. So let's just write it out a bit more detail. So 00415, let's say, centimeters. Okay, great. So now we've done the green one. Let's maybe try and figure out the yellow one. Now I've got another right angle triangle here, where this is our right angle. Think of it being flat on the floor. Now I can use Pythagoras here. So again, I'm just gonna take this triangle out of the diagram, if I can find the question again. So I'm going to take this triangle out of the diagram. So I've got another right angle triangle where this is 30 and this is 20. Okay, and we'll call this y. So again, we can figure it out using Pythagoras. So we've got a squared plus b squared equals c squared. This time y is the hypotenuse. So y squared is going to be 30 squared plus 20 squared. So y is just going to be the square root of all this. Okay, so again, I use my calculator. So square root 30 squared plus 20 squared. And I end up with 10 root 13 centimeters. Okay, and that is this line here, 10 root 13 centimeters. Okay, great. Now finally, I can figure out this A to F. Well, we want this angle here, don't we? This, let's colour it yellow now. So this angle here. So let's redraw this. We're going to redraw our orange triangle. So it's looking a bit like that. We want to know that angle, which we'll call Z. And this is a right angle. And now we know that this bottom of it is 10 root 13. And we know the side of it is 14.00415. And this is in centimeters. Okay. So again, we want to use trigonometry. So let's label our sides again. So this is the hypotenuse. This is the adjacent. This is the opposite. It's looking like tan again. So we're going to have tan of Z. It's going to be opposite, which is 14.00415. Oops. Divided by the adjacent, which is 10 root 13. And so Z is going to be tan to the minus 1 of all of this. Okay, then we'll see what we end up with. So shift tan, we've got 14.004, is that 415, yeah, over 10 root 13. Okay, and we want our answer to 3 significant figures, so that is going to be 21.2 degrees. All right, so a lot going on there. I'm hoping they're giving me a meaty amount of marks. 4 marks for that. Stingy, aren't they? What was it? 21.2. Okay. There we go. Okay, next question. So number 19. So the table shows information about the time in seconds taken for people to run a 100-meter race. So 6 people took between 10 and 12 seconds. 21 people took between 12 and 13. 23 people took between 13 and 14 seconds. We don't know how many people took between 14 and 16. And 8 people took between 16 and 20. So it says use the information on the table to complete the histogram. Okay. So a histogram has what we call frequency density, which basically means that the area of the squares, or the rectangle, sorry, is going to give us the frequency. So the first thing we might want to think about is the width of the boxes. So the width times the frequency density is going to give us the frequency. So the width of this first box between 10 and 12 is 2. Then that width is 1, 1, 2, and 4. Okay, now let's look at what box we've got. Now here we've got between 16 and 20. Now the box width is 4 and we're ending up with 8. So that's got to be 4 times 2. So 4 times 2 gives me 8. So that makes me think that this line is going to match up to 2. And that's going to give me my scale on the left hand side. So if that's 2, that's going to be 1, 2, well it's going up to 5, isn't it, for every big square. Okay, and then 25. All right then, so now I can use that to complete the histogram. So here we want to look, well, 4 times what is, so we're going to do our frequency density in this column here. So this is frequency density. So 4 times what is 8? Well, it was 2, we just did that. 2 times what is 6? Well, it's 3. 1 times what is 21? Well, it's 21. 1 times what is 23? It's 23. So here we should be able to fill out our things. So let's just double check. I'll just zoom out. Sorry, it's hard to keep it all in one place. So between 10 and 12, we want a frequency density of 3, which is going to be there. So that's between 10 and 12. And then from 12 to 13, we want to go up to 21, which is there. So that is between 12 and 13. And then between 13 and 14, it's 23, which is up there. Okay, so I've used the information to complete the histogram. And then finally, it says use the histogram to complete the table. So we just want to look at this thing here. So the width is 2. And we want to think, well, 2 times what is going to give me 21? Yeah, so this frequency density is 21. So the frequency density is 21, so then we just want to do 2 times 21, which is 42. And that's going to give us our frequency between 14 and 16. Okay, number 20. So F is root G over H, where G is 12.7 correct to 3 significant figures, and H is 9.294 correct to 3 decimal places. By considering bounds, work out the value of F to a suitable degree of accuracy. Okay, so let's first think about G. Now G is 12.7 correct to 3 significant figures. So the way we think about what the lowest it could be and the biggest it could be is think about what was before and after it. So to 3 significant figures is 12.7. So previously that would be 12.6 and after that would be 12.8. And then the way we find the bounds is we just think about the halfway points. Just draw that a bit better between them. So this would be 12.65 and this would be 12.75. So this is for G. Okay, so those are our bounds for G, 12.65 and 12.75. Now, if we think about H, well, that was 9.294 to 3 decimal places. So again, you think about the previous one, 9.293, and the next one, 9.295. And again, we just think about the halfway points, which would be 9.2935 and 9.2945. And that's not F, sorry, that's H. So those are our bounds for H. Okay then, so now we want to think about the value of F. What's F going to be? So let's think about the lowest it could be and the highest it could be. So F, let's say lower bound, FLB. Now when is this going to be smaller? Well, this is going to be smaller when G is smaller, but when H is bigger, because if you're dividing by a big number, you're going to get a smaller number. So this is going to be, well, let's just write it out a bit. So this is going to be G lower bound, and it's the square root over H upper bound. We want H to be bigger. So this is going to be the square root of, well, the lower bound of G was 12.65, divided by H upper bound, and the upper bound of H was 9.2945. And that's going to give me, so square root of 12.65 divided by 9.2945, and we end up with 0.382665431. Okay, now let's have a look at the upper bound of F. So let me grab a different colour that we've not used yet. Let's use this kind of grape colour. So F upper bound. Well, that's going to be highest when G is highest, so G upper bound, and when H is lowest, because you're dividing by a smaller number, so H lower bound. So that's going to be the square root of 12.75 for the upper bound of G, and the lower bound of H is 9.2935. And so that's going to give us, so again, I'm just going to actually edit my numbers, so 12.75, and then at the bottom 9.2935. And that's going to give me 0.384216333. Now we want to work out the value of F to a degree of accuracy. Now we know that the highest it could be is this, and the lowest it could be is this. But you'll notice that the first 2 points after the decimal are exactly the same, 0.38. And as well, because we've got a 2 after it here, it will stay at 0.38. And because we've got a 4 after it here, it will stay at 0.38. So no matter how high or low F is going to be, we know that F is going to be 0.38 to 2 decimal places. Okay. All right, so number 21, we've got 2 right-angled triangles. And so this one has got sides x and 4x plus 3, sorry, and an angle of A. And this second one has got 3x plus 2 and 27x plus 4 and an angle of B. Now it says, given that cos A equals cos B, find the value of x. Well, this to me, we've got coses, we've got right-angled triangles, it's got to be trig, hasn't it? So cos of A, if we use trig, so let's just label our sides again. And it's going to be the same for both. So cos is adjacent over hypotenuse. So cos of A is going to be x over 4x plus 3. And cos of B is going to be, so similarly on this triangle, it's going to be A, which is 3x plus 2, over H, which is 27x plus 4. Okay. But this is telling us that they equal each other. So we've got that cos of A, which is x over 4x plus 3, equals 3x plus 2 over 27x plus 4. So that's the first bit of reasoning, that we get these equal things. Okay, well now we want to work to solve them. And we've got fractions, which are not nice. So we want to times up, do this kind of cross multiplication. So if we times up by 27x plus 4, we're going to get x brackets 27x plus 4. And that equals on the left, if we times up this 4x plus 3, we're going to get 4x plus 3 times 3x plus 2. Okay, next step, we're going to expand these brackets. So this is going to be on the left, 27x squared plus 4x. And on the right, we're going to get 12x squared plus 8x plus 9x plus 6. If I just simplify that slightly on the right hand side, we're going to get 12x squared plus 17x plus 6. Okay, now I want to bring everything to the left hand side. So 27x take away 27x squared take away 12x squared is going to give me 15x squared. 4x take away 17x is going to be minus 13x. And minus 6 is going to be 0. Okay, great. Now we've got this, I'm going to use the quadratic formula. So again, that's in the front of the exam. So I've just realised that I look like I'm living in a cave. Let me just turn this light on briefly, if I can remember how to do it. No, maybe I unplugged it. All right, so we're going to go for the quadratic formula. So this is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. So here we've got a is 15, b is minus 13, and c is minus 6. So we're just going to plonk these into here. So minus b is going to be 13 plus or minus the square root of minus 13 squared minus 4 times a, which is 15, times c, which is minus 6, all over 2 times 15. Okay, now we're going to put all that into our calculator. So 13, we'll start with plus square root of minus 13 squared. Make sure you put that minus 13 in brackets, otherwise you're going to get minus 13 squared, if that makes sense. So minus 4 times 15 times minus 6 over 2 times 15. Now the plus version gives me 1.2. And then if I go back and change that plus to a minus, I'm going to get or minus 0.3 recurring. But if we look at it, x can't be minus 0.3 because you can't get a negative length. So it must be this. So it's 1.2, and I think we were in, it doesn't actually say what the units are, so we'll just leave it as 1.2. Okay. All right, number 22. So we want to solve algebraically the simultaneous equations x squared minus 3y squared equals 13 and 2x plus 3y equals 4. Okay, so when you get ones like this, where it is a quadratic one and then a linear one, you always want to solve the linear one first for x or y. So let's solve this one to start with. So we've got 2x plus 3y is 4. We can solve it for x or y. Let's just do x. So take away the 3y, we're going to get 2x is 4 minus 3y. And so x is going to be 4 minus 3y divided by 2. Okay. Then what I want to do is I want to shove that into the first equation. So we want to shove that into this red one here. So x squared, well, now we know that x is 4 minus 3y over 2 squared minus 3y squared equals 13. Okay, well, if we square the top, that's going to be, well, let's just write it out. 4 minus 3y times, 4 minus 3y divided by 2 squared, which is 4. Then we've still got minus 3y squared equals 13. Okay, now let's times everything by 4 and let's expand these brackets out at the same time. So 4 times 4 is 16. 4 times 3y is minus 12y, and we've got 2 of those, that's minus 24y. And then minus 3y times minus 3y is plus 9y squared. So I've times by 4 to get rid of that fraction. So I've got to times everything by 4. So minus 3y squared is going to be minus 12y squared. And 3 times 4 is 12. Okay, so I don't like that I've put these equal signs here. Okay, so now let's just tidy up a little bit. So we've got 9y squared and we've got minus 12y squared. So altogether we've got 16 minus 24y minus 3y squared equals 12. Okay, so let's bring everything over to the right hand side. So that's going to give us something nice. So if we add 3y squared, we're going to get 3y squared, add the 24y, and then take away the 16, and we're going to get minus 4, and that equals 0. Okay, so again, we've got this, and now we want to look at if we can solve it. So let's use the formula again, the quadratic formula. So again, we're going to get y equals minus, so I'm just going to go straight into it. So minus 24 plus or minus square root of 24 squared minus 4 times a times c over 2a. And that should give us two options. So minus 24. Let's start with plus 24 squared minus 4 times 3 times minus 4 divided by 2 times 3. And so our first option is 0.16333199989. Or our second option is going to be minus 8.163331999. Now, these are nasty numbers, so let me just double check that this feels right. So it's not telling us to do it to a certain number of decimal places or anything like that, which makes me a little bit worried that I might not have done it correctly. So this is a good opportunity then. So this is kind of like an exam technique where my spidey senses are tingling. So it's making me think that I've done something a little bit wrong. So let's just double check we've done every step correctly. So 2x is 4 minus 3y, so I'm happy with that. 4 minus 3y over 2 minus 3y is 13. Oh, there it is. Okay, so I've just lost my 1 there on my 13. So this is going to become, so let's just go back and fix that. So 13 times 4 is going to be 52. So that is 52. And then 52 minus 16 is 36. Okay, that's going to make life a lot easier, I think. Okay, so let's rub this out. Okay, good. So nice little thing there. So if it had said something like, give your answers correct to 3 decimal places or something like that, I'd have thought, okay, maybe I'm on the right track. But the fact that it didn't, and the fact that I didn't get nice numbers made me worried. Okay, so now actually I'm noticing that all of the terms here can be divided by 3. So this is going to become y squared plus 8y minus 12 equals 0. Okay, now that looks a lot nicer to me. And I think we can also, can we factorize this? Is that going to be something nice to do? Let's think. Oh, and that's, yeah, okay, and that's the, yeah, and the other thing, this is not going to be a minus, is it? It's going to be a plus. Okay, there we go. Okay, right, so we're nearly there. All right, so now we can factorize this. So times to make 12, adds to make 8, that's y plus 2, y plus 6 equals 0. We solve that, we get y is minus 2 or minus 6. Lovely. Okay, so now I'm thinking we're back on track. So we want to put those numbers into well, one of the other equations. Let's do the easy one. So 2x plus 3y equals 4. Okay, so if we've got, let's do it in different colours so we know what we're doing. So if we've got y is minus 2, so y is minus 2, we get 2x plus 3 times minus 2 is 4. So 2x minus 6 is 4. So 2x is 10 and x is 5. So that's our first option. And then secondly, let's grab a different colour for minus 6. So 2x plus 3 times minus 6 is 4. So 2x minus 18 is 4. So 2x is 22. So x is 11. And that was for y is minus 6. Okay, so those are our two options we got there in the end. Okay. Right, so I think this is, we've got an extra question, but this is the kind of last official question of the paper. So there are some red counters and some blue counters in a bag. The ratio of red counters to blue counters is 3 to 1. 2 counters are removed at random. The probability that both the counters taken are blue is 1 out of 20. Work out how many counters were in the bag before any counters were removed. Okay, so we don't know how many counters are in the bag, but we've got this ratio. So let's say that this is x for 1 and this is 3x. And that's going to be our total. So our total is going to be 4x counters. Okay, now we want to know the probability that both the counters are blue. Well, the probability that the first counter is blue, so the first is blue, is going to be, well, blue is 1x and the total is 4x, so that is 4x, so this is the probability of this, x over 4x, but divide, cancel out the x's, this is 1 over 4. So the probability that the first counter is blue is 1 over 4. Now the probability that the second counter is blue, given that the first one is also blue, well, how many blue ones have we got left? Well, it's going to be whatever x is minus 1, divided by, well, how many have we got altogether? Well, that's going to be 4x minus 1, because we've taken 1 out, haven't we? And that is left like that. So, the probability, let's grab a different colour, so the probability that both are blue, we're going to times these together. So this is going to be 1/4 times x minus 1, over 4x minus 1. Okay, there's too many brackets going on there, but you get the idea. And we know that that is 1 over 20. Okay, so now let's see what we end up with. So we're going to get 1 over 4. So let's times both sides by 4. So we're going to get x minus 1 over 4x minus 1 is 4 over 20. But 4 over 20 is just 1 over 5. So now I want to times up by these fractions. So let's get the 5 up to the left. So 5 brackets x minus 1 is going to equal 1 lot of 4x minus 1. Let's expand this. So 5x minus 5. Don't like that I'm putting these equal signs here. So let's get rid of them. So 5x minus 5 is 4x minus 1. Take away the 4x from both sides. We get x minus 5 is minus 1. Add the 5. We're going to get that x is 4. Now remember, the question's asking how many counters are in the bag. Now we know that it's 4x. So 4x is going to be 4 times 4, which is 16. So we think that there are 16 counters. Okay, so that's the end of the paper. They've given you a little bonus question. That's nice of them. So let's just do it. Why not? So the number of people living in a town t years from now is pt, where p0 is 55,000. and pt plus 1 is 1.03 brackets pt minus 800. So this is like a recurrence relation problem. So work out the number of people in the town 3 years from now. So we're just going to have to do the same thing 3 times. So we know that p0 is 55,000. So p1, using our formula, that's going to be 1.03 brackets p, the one before, which is 55,000, minus 800. And that is going to be, so we'll just use our calculator, so 1.03 brackets 55,000 minus 800. That gives me 55,826. Okay, and then we just keep going. So P2 is going to be 1.03 brackets, the previous one, which is 55,826 minus 800. And that is going to be Now that is going to give me 56,676.78. And then finally, P3, which is what we want, is 1.03 times this, 56,676.78 minus 800. And that is going to give me 57,553.0834, or to the nearest person, 57,553. All right then, so that's that paper. So that one, because it had an extra question, was out of 83. I'm sorry that I've been talking to you in the dark, but I hope this was useful, and good luck in the exam on Monday.